Hey, this is lecture 8D, so the fourth lecture in chapter 8. In this lecture, we're going to cover topics of electrolytes and non-electrolytes and also the concept of solubility. This helps us understand what dissolves in water and some of the properties once something dissolves in water. So previously, we've talked about aqueous solutions. Aqueous solutions are solutions that have water as a solvent. When you dissolve ionic compounds in water, you produce ions. We'll look at this in a couple of slides. But when you have these ions present in water, it conducts electricity, which is shown here. This electricity is flowing through this solution, lighting up the light bulb. And this just tells us that there are some ions present that can conduct electricity. So if we look at some examples of different solutions, we have pure water, distilled water. There's no ions in here, so this is a non-conducting solution. If we put sugar in water, this is also a non-conducting solution, which means that sugar is a non-electrolyte. Sodium chloride, on the other hand, does conduct electricity when dissolved in water, so this is classified as an electrolyte. So what makes something an electrolyte or non-electrolyte? It's a result of how that substance dissolves in water. When we are dealing with electrolytes, we are dealing with ionic compounds typically. And what happens with something like sodium chloride, which is an ionic compound, you put that in water, the sodium chloride dissociates, means it breaks up into sodium ions and chloride ions. So an ion is just a charged particle. It can either be an atom, in these cases sodium or chloride, or a group of atoms. When we talked about polyatomic ions, those are groups of atoms. We can classify these as cations, positive charge, or anions, or negative charge. When you dissolve sodium chloride in water, these ions dissociate and water surrounds them, and this is how they become solution. There are a bunch of solubility rules that help us predict if an ionic compound will dissolve in water. This is not something that you need to memorize. If you were given this table and given a compound, you could predict if it was soluble in water. So any ions or any ionic compounds that contain sodium are all soluble. So our sodium chloride that we looked at previously is soluble in water. Something like sodium nitrate is going to be soluble in water. Typically, nitrates are also always soluble. Chlorides, most of them are soluble. We looked at sodium chloride, that is soluble in water. But you do have some, such as mercury chloride and silver chloride, that are insoluble. So from this table, you can predict if something's going to be soluble or insoluble. And we say insoluble, it means that it doesn't dissolve to a large extent. So it means that the molar concentration of those ions is less than 0.1 molar. This does not mean that it doesn't dissociate at all. So for an example, you can have something like mercury chloride, which has a very low solubility. It would be considered insoluble, but the amount that does dissociate is enough to cause toxic effects to humans and other aquatic organisms. So let's look at ionic versus covalent compounds. If we have an ionic compound such as sodium chloride, as we said, that this dissolves in water and conducts electricity. It dissolves in water and produces sodium and chloride ions, cations and anions. These charged species conduct electricity. If we have something like sugar, this is a covalent compound. It contains all nonmetals. This dissolves in water. You put it in water and it is soluble, but it does not conduct electricity. This is because ions do not form. So let's take a closer look at sugar, the sucrose molecule. these are covalent bonds. So when sucrose dissolves in water, the sugar molecule interacts with that water. The water surrounds that whole molecule, but it does not dissociate to form ions. So you don't lose any of the individual atoms from the sucrose molecule to form a charged species. Covalent molecules remain intact when dissolved in water, and therefore they are non-electrolytes. When we're looking at solubility, another important concept is like dissolves like. What we mean here is that for a solute to successfully dissolve in a particular solvent, they have to be like each other. And what we're referring to here is polar versus nonpolar molecules. As we have said previously, water is a polar molecule. Therefore, compounds that are polar will dissolve in water. Sodium chloride, sugar. These are both polar molecules. Remember, when we're talking about polar molecules, it means that the electronegativity of different atoms differ. So therefore, you have a charge distribution that is not even throughout the molecule. Polar compounds, polar dissolves in polar, sodium chloride and sucrose dissolve in water. Nonpolar compounds do not dissolve in water. An example of this would be oil. Oil is a nonpolar molecule and therefore it does not dissolve in water. It would separate. You don't have that oil dissolving in the water. Based on this picture, we can say that the water is more dense than the oil since the oil is sitting on top of it. We do have the ability to enhance the solubility of something in water, and we can do this by using a surfactant. Soap is an example of a surfactant. And the way a surfactant works is it's typically a large molecule, and a portion of that molecule will be polar and a portion will be nonpolar. So, for example, the nonpolar portion of the soap molecule might dissolve that oil, whereas the polar portion will attract the water and allow that oil to then be slightly soluble in that water. This is why we use soap to clean our hands. It helps us get something that might not dissolve in water off of our skin.